This is a short movie to show you how to use our demonstrator that we've written for the ISWS Summer School. Before you can use this demonstrator, you need to have installed MetaMask in your browser, and you need to have created yourself a solid pod. You can find information on how to do this on the website for the Summer School. So first, on the first tab, we need to connect to everything. So let's connect to MetaMask. Now we're connected and you can see the account that we've selected. Now it's important for the purposes of using our demonstrator that you're connected to the correct network. So we're using the Rinkeby test network. That's where we've created our token contract and that's where we've seeded you the money for your accounts that you'll have been given by John. Then we connect to our solid pod. And we permission the page, talk to it. Okay, so once you've connected, you'll get your web ID. The first part of that is also the URL to your pod. And you then, into this bar, we need you to put the folder in your pod where you want to store all the data that you might be saving from the other tabs. So I created myself a folder called ISWS just for using the demo. And we have a button there to read all the files from whichever pod folder you've specified here, so I can see all my test data from my previous tests as they are up on Solid. So now you're all set up to use the rest of the demo. There are several stages to verifying your RDF data with link chains. On this first tab, you're going to choose some RDF data and you're going to get the verification metadata from link chain. That is the first step in securing your RDF. So you can either read a local file, you can pull a file down from your solid pod, or you can paste directly into this box. So I'm going to use a small test file I've been using. There we are. And I'm going to read it in. Now I can also choose to save it up to my pod or read a different file from my pod. So this is my RDF input that I want to secure with link chains. So the first thing I'm going to do is ask link chains to give me some verification metadata. Link chains will return to you JSON LD with a Merkle tree of hashes to represent your quads. So that's the first stage in this process. So you can save that up to your pod. You can copy it out to a local file, depending what you want to do. And that's put a copy of that information for the verification metadata up into my pod. If you do all these tabs in one go, it will be preceding bits for you, but you can obviously come back and do individual tabs separately at any point. So we provide in this demonstrator two different ways to anchor your RDF verification metadata to the blockchain. The first, on tab 3A, is to anchor it with the Merkle anchor contract. So here, again, you can choose a local file, you can pull it from Solid or you can paste into your pod. Now it's preceded the verification metadata I created on the previous tab, and that's what it's going to require to anchor to the blockchain. So by one of these methods, you need to put your verification metadata into this input field and then press anchor. It's going to open MetaMask for you and it's going to ask you to confirm the transaction on the blockchain. So just double check you're on Rinkeby and confirm that you want to put it on the blockchain. In the background, that's creating a new Merkle anchor contract and seeding some data into it. You have to wait for it to be mined, and there you are, you have a confirmation that it's been mined. And then link chain gives you back anchored verification metadata. So that's the verification metadata with an anchor section appended that shows you how it's been anchored to the blockchain. So it's got the address of the contract, the account that anchored it, and the transaction hash. Right. Okay, now you can store this somewhere. So I'm storing up to my solid pod. Now the other way you can anchor metadata in this demonstrator is by putting it in as a token into a token contract. So we've created an RDF token contract and we've put an instance of that token contract on the Rinkeby chain, and the demonstrator knows the address of that. And so on this page you can take the same verification metadata and anchor it as a token. Now tokens by default have a name, a description and an image to associate with them. So these are non-fungible tokens that we're talking about, or NFTs. So I'm going to give it a name, a description, make it something more sensible to do with your RDF dataset, and then it can take an image. We filled a pre-defaulted image in there. If you want to change that, you just need to put in a URL to a different image. It can be doesn't have to be SVG, it can be ping, I believe. Right, so now it's got all the data to go into the token. We're going to anchor it again to the blockchain. This time in the background, it will be writing an entry to the token contract, giving it a unique token ID, and storing this data and the anchoring data into IPFS as the metadata for the token. So again, it will prompt MetaMask to open and ask if you want to write to the token contract. And you confirm. And again, you have to just wait while it's mined, and you'll get back a confirmation from MetaMask once it's gone onto the blockchain. And there we are, it's gone on. And then again from LinkChain, you get back your anchored verification metadata. But this time the anchor consists of a token ID as well as the address of the token contract and the hash and the account that did the anchoring. So we can store this. Okay, I've put that up on my pod. Right, so now you've got anchored metadata for your RDF. Now there are two different ways you can validate that data with link chains. You can validate the entire set in one go, and it'll tell you whether anything at all in that set has changed, or you can validate it at a granular level, which will tell you if a single piece of information, a single quad, has changed in that data. But in order to do the validation that's granular, you have to get granular metadata first. So to get granular metadata, you need to give it your input RDF, which has been preceded when we loaded it before, and you need to load your anchored metadata. It can be either the one you create on 3A or the one you created on 3B. It doesn't matter. And then you ask link chains for the granular verification. What this gives you is a much more complicated set of JSON LD that has a separate proof for every quad in your RDF dataset. So you're going to need to store that somewhere. Let's put that up. Okay, now you have everything you need to do to validate. So let's start with the simple validation first. So this takes your input and it takes your anchored metadata, either version, whether it's 3A or 3B, and it tells you whether anything in your dataset has changed. And because this is an all or nothing verification, you will either get back all your quads under verified or all your quads under unverified. In this case, I haven't made any changes to this data, so it's all come back as verified. Now you can also get it to give you a little bit more granularity on the verification. So here, if I make a little tweak to something, so let me change this biomass to 70. I've made a little tweak. This has preceded my granular metadata that I created on the previous tab, but you could load it from Solid or paste it into the box or read it from a file if you'd saved the granular metadata locally, and then you validate that. This time it's mostly come back as verified, but you will see that it has returned one quad as unverified, and that's the mass that I just fiddled from 69 to 70. So it's identified that that particular quad was changed from the original data. So that's showing you all the aspects of the demo that deal with link chain, that deal with MetaMask. So every time you store to the blockchain or read from the blockchain, you're doing so through MetaMask, and obviously storing and reading from your Solid pod. There is an admin tab at the end. If just as a demonstrator, if you want to, you can publish a separate token contract on a different chain or on the chain with your own contract ID and write to that. So that's just left from our administration when we published our token contract. All the source code for this demo is up on GitHub, so you can pull a whole copy. It's all client side. There's no server interactions here. It's calling different APIs. You can see the documentation on the website with an architecture diagram showing you. So you can pull the whole lot down to your local machine and edit it, change the bits, look at how bits are being done, and modify it as you need to complete your summer school project. Thank you.